One of the best example of this system is Arden syntax, which was quite common in early 80s, late 90s. But they had their limitations because they were not capturing all the nuances and the way we make decisions. So what John did different, he came up with a model or framework for this capturing clinical knowledge or what and planning and decision making. And this part of AI is called knowledge representation. And in knowledge representation, you are not only focusing on just the rules, which is part of it, but it goes some levels below, above the rules. For example, if you start a knowledge ladder, I will say the basic concepts are like terms or symbols, which come from like images, pixels, or terms in a structured data. Next level to it is a description or concept. So from those terms, we form concepts. From the concepts, then we infer rules. And from the rules, then we make decisions. So in decisions, when as a clinician, I'm making a decision, it is not just based on a single rule, like if then, and that is the limitation of then expert systems. So for example, if I want to give a rule or create a rule, says that if a patient had a bypass surgery, then you put the patient on, let's say, blood thinning agents. So that is a if then rule. But whether I would put the patient on blood thinning agents depends on other factors as well. For example, whether that blood thinning agent is going to cause any other harm like the benefit, and that could be a brain hemorrhage. And then what is the certainty of brain hemorrhage or whether versus the certainty of getting benefit from this anti-platelet or blood thinning agent. And so decision making is a complex task, cognitive task, where you are judging pros and cons or benefits and harms and the certainty of those different factors. And once I take the decision, then basically I will plan the treatment that is called clinical workflow. So I'm not going to just say, okay, now we start this patient straight away on the blood thinning agents. I have to say when, what time, how long I should be continuing. So there is a planning involved. And all this is happening in me or a clinician, any clinician as an autonomous agent. So what John did is he borrowed the concept of logic from expert systems, but on that he added this decision functionality. Then he added this planning functionality and the agent functionality. So he created a model called Proforma in mid-90s, which won then the European gold medal. And that model, Proforma, becomes the kind of underpinning framework for developing all the technology that Deontics has developed. So we started with old AI, as we call, which is expert systems, but expert system with this additional functionality of knowledge representation, which is very similar to the way humans represent the knowledge, called knowledge representation. And then we added the new technology stack from all the latest technology available, and it is continuously improving. Now, if I compare this with the contemporary AI, I mean, when I joined John's lab, AI was a fashionable term. It was not as commonplace as now. So for me, AI in medicine was I didn't know that. And I really got interested personally because of two things. One thing is his technology was very intuitive for a clinician like me. So I could understand it was not a black box. And second thing is he had also deliberately hidden the complexity of the model and the technology away from the user or the author, not user in a sense of a clinician, but the author who is creating those applications. So I could create application myself very easily without any programming knowledge. Previously, all these expert systems, programmer is used to create those applications. And as you can understand, if programmer without a clinical domain knowledge is creating those applications, they cannot embody all the nuances and the complexity of the domain which they are creating applications for. So one of his, I would say, major contribution was creating an authoring system for a non-programmer or domain expert, for a clinician who can use it easily. And that's how I got interested in that, in the concept of this clinical decision support in the first place. And second, it was giving this nuance information as a decision maker, whether there are pros, cons, probabilities, and all weighing explained. Now comparing this with current machine learning concept in AI, because whenever we talk AI nowadays, people forget that AI started in early 70s and it has gone through multiple AI waves. So this is probably a fifth AI wave. And we are talking about here specifically machine learning algorithms, or very recently large language models, LLMs. So in machine learning and LLMs are a different concept in AI compared with the knowledge representation. Machine learning and LLMs both use learning by example, which is, uh, I would say, entirely different concept. At the same time, it is complementary to the knowledge representation concept in AI, and they have got different applications for different problems. So machine learning is useful in certain problems, while old-fashioned knowledge representation is useful in certain domains. And I will give you an example. So a domain which is where you are following guidelines or rules, and where you need to have a predictable outcome. For example, if you are giving certain inputs or certain patient parameters, you always expect that certain treatments are recommended. You can't say that for the same patient, if I put this input today, I will get a different recommendation, and again 5 minutes later I will get a different recommendation. That won't work. And one of the problems with applying ML and LLM to these type of problems is there is no guarantee that they will give you the same recommendation. So in the areas where treatment planning, old-fashioned AI is really useful, while areas where you are predicting something or you are classifying something, then the machine learning or LLMs are useful. To give you an example, I would say if you have a data of a patient and you want to find out what are the chances of the cancer coming back. So there you are using regression. That is what machine learning can do much better than knowledge representation. Or another example is if you have got an image from either a pathology slide or an imaging slide, where you want to recognize the pattern, classify them, and say what are the chances of this particular pathology or the slide representing cancer, then machine learning is very useful. So there are different application domains or the different problems they suit better. But there is a complementarity as well in these two. So in areas in medicine especially, like when you are doing a lot of things together, right from diagnosing, workup, treatment planning, you can apply these selectively in different areas. So that's why I think these are two complementary technologies, and I would certainly like to basically do more work in this area of how we can combine those technology, where Deontics at the moment is mainly focusing on knowledge representation, and there are many upcoming large language model technologies which we can then combine together. So that is ongoing work, which ongoing research which we are undertaking.